Hello guys, what is up? Welcome to Radco Academy. In this video, we are going to look at variation. Okay, look at variation. This is grade 11 mathematics. So in variation, we have two kinds of variation. You have direct variation. When you have two relationships, that varies direct. You have y varies direct as x. So you write the symbol like that one. So this is how you do the direct variation. Now the direct variation is between y and x. Of course, it can be any variable. Now this symbol simply means varies. Okay. This symbol means varies. Now you have to remove this symbol and introduce what is called the constant. The constant, which is just k. So this is a constant of variation. So in this case, this one is just going to be y is equal to, and then you introduce the constant and x there now. So that is how you go about in direct variation. And now in inverse variation, so under inverse, you are going to say when this variable increases, the other one reduces. So there is it's a fractional thing. So where you put 1 and then varies like that one. So once you do that, you introduce the constant. It's going to be k, and then open bracket 1 over x. Okay. And then now from there you can just simplify as k over x. So this is about inverse variation. And the other important thing that you need to understand also is that direct variation can be combined with this thing called joint. Okay. So where you talk about the joint variation. So a joint variation is where you have now you include another variable other than x. So it can be y is equal to k, x, and z, for example. So that is a joint variation. And then when you talk about the partial variation, it's now the partial is connected to the inverse. And again, for the partial, you need to have more than one variable in terms of variation. So the partial, so for the partial, this can be y is equal to k divided by x, z. Okay. And this is what we call a partial variation. So the moment you understand this concept, okay, you have to be very careful. You must be able to identify which one are you dealing with. Okay, so now let us look at the examples, okay? So let us look at the examples, and so that we can understand how you can go about these kind of variations. So our example 1, we'll look at direct variation. Okay, so in this case we have say given that y varies directly. So this is how you can know that this is a direct variation. Y varies direct as x, okay, and as x, and y is equal to 2, and x equals to 1. So the first thing that we do is they'll ask you find the constant. Find the constant, which is just k. Then other than that, now follow the question. If x is equal to 4, find the value of y. Okay, so what you need to understand there is that how can you go about this one? So remember, this is a direct variation. Since they have said, given that y value is direct as x and y equals to 2 and x equals to 1. So find the constant k. First of all, you must come up with the relationship between y and x, which you know is that direct variation. So I'm just going to say y value is direct as x. So from there now we can introduce the constant y equals to kx. So remember what we said about direct variation, this one, okay? So from there now, we know that y is given as 2 and x is 1, so we can just substitute. So it's going to be 2 equals to x, open the bracket, and then the k is 1. I mean the k, open the bracket, x is 1. So this is just going to be 2 equals to k. And therefore, the value of k is simply just 2. So that's how you can find now. So now for the value of if x is 4, find the value of y. So for number 2, it's going to be, you must use the same equation. Okay, so y equals to kx. So we are finding the value of y given that x is 4. So this is going just to be y, the k is 2, so you put there just 2, open the bracket. Our x is given as 4. So our y now becomes y equals to just 8. So 2 times 4 just 8. And that's a value of y. So that is an example on direct variation. So let's go to, so now inverse variation example, okay? So example 2 on inverse variation. So the question reads, given that y varies inversely, y varies inversely as x and y equals to 3 and x is equal to 4. So one is find the constant. So the first thing is to find the constant. So the constant k. And then number 2 is now to find, and now it's saying if y is equal to 36, find the value, of x. Okay, so let us look at how you can go about this one. So we know that if you are talking about inverse, then it's something that we have as a fraction. So y on number 1. So first of all, you have to get the relationship is inversely. So y varies inversely as x. Okay, so now the moment you do that, introduce the constant k. So is y is equal to k, open bracket, and then 1 over x. And this is now going to be y equals to just k over x. Okay? So from there now we know that the value of y is 3 and the value of x is 4. And from there now we can now say y is equal to k over x, of course, and then y is 3 and our k is what we're looking for, our x is 4. So this one is a fractional thing, so you say over 1, you cross multiply, and 1 times k, just k, and 3 times 4, this will just give you 12. And that's the value of the constant k. And then number 2, now they are saying that if y equals to 36, find the value of x. So you still use the same equation, y equals to k over x. Okay? Now from there, we're going to say we are finding x. So where is y, we are going to put 36. So we are going to say 36 equals to, our value of k is 12, then over x. So from there, you cross multiply, this is going to be that. 36 times x is just 36x equals to 1 times 12, just 12. Then you divide by both sides by 36, and this is just going to be 2 there. It just, 6 into 12 just 2. 6 there is just 6. And they're just going to have this. And our x is 2 there, it's 1. 2 here, it's 3. So that's a value of x. Okay. So now we move on to the joint. Okay. So joint example 3. Okay. So in the joint, we are saying that okay, so in joint example, joint valuation, given that y Okay, so under joint variation, you're saying that given that y varies joined to the as x and as a square of z, y equals to 1, x equals to 3, and z equals to 2. Find the constant k. If x equals to 2 and z equals to 1, find the value of y. So, like I said, joint variation is just a complex direct variation. So all you have to do is just say on number 1, so it's the equation connecting y, x and z is just y is just values as x and the square of z. Okay. Now you always remove this and introduce the constant y equals k, then x z squared, and this is just k x z squared. Okay. Now we know that y is given as 1, x is 3, and z is 2. So y is 1 is equal to k, open the bracket, x is 3, okay, and the z is just 2, then squared. So this one is just going to be k, then this is 3, okay, and this is 4. And this is going to be 1 equals to 12k. And now when you divide, it's going to be 12, 12. And therefore, the value of k is 1 over 12. So that's the value of k. And now to find the value of y, then we are going to still use the same formula. Y is equal to k x z squared. And this will be y equals to 1 over 12. Okay. And multiplied by the x is now 2. And the the z is given as 1. So it's 1 squared. So this is going to be y is 1 over 12. Then multiplied by 2, multiplied by 1. Then from there now we can say y equals to just 2 over 12, which is just 1 over 6. Okay. 2 there it's 1, 2 here it's 6. Okay, so that's how you can go about finding that. Now the last one is about partial, which is connected to inverse variation. Inverse variation, and now in partial, meaning where you have more than one variable on your right. Okay. Okay, so the last example is about will be on partial. So this is example 4, and we'll be looking at partial. So partial variation. Okay. So under partial, we have an example which says given that y varies inversely as a square root of x and the square root of x, and the values is also for z. So this is inversely as a square root of x and z. Now where y is equal to 10 and x equals to 4, and now finally z equals to 1. So the first question is find the constant. Find the constant k. And also finally, if x equals to 2 and z equals to 1, find the value of y. So now in this case, what you're supposed to do is this is a partial, okay, so it's inverse, okay. So now what you're going to do is first find the constant. Before you do that, then you have to look at the what is connecting y, z, and x. So it's y values. So it's a 1 over, meaning we have the square root of x, and also values as inverse as z. Okay. So this is now after you remove this symbol. You say now y is equal to k, open bracket, 1 over the square root, okay, square root of x times z. And now this is going to be y equals to k, y equals to k over root of x and this z. So now we know that the value of these values is 10, the value of y, so you replace 10 equals k is what you are looking for, and the root of x, which is just x is 4, okay, x is 4, this one. So this is going to be 4, and I multiply by z, and z is just 1, okay, so times 1, and this is just going to be 10 equals to k over the root of 4 is just 2 multiplied by 1 is just 2. Then we cross multiply. So this is just 10 multiplied by 2. This will give you 20. Okay, that's the value of k. And then number 2, now they're saying find the value of y. So to find the value of y, you still use the same equation, y equals to k over root of x multiplied by z. Okay, now this is going to be y is what you're looking for. The value of k is 20 divided by root of x is just 2, okay, this is 2, and x is just 2, this root of 2, and z is just still 1, okay, and this is just going to be this 20 divided by this is same as saying 2 to the power half, okay, and once you do that, then we can use your calculator, okay. Okay, so the square root of 2, so you say 20 divided by 1.4, and this is just going to be So your answer is just going to be 14.43. So this is the value of y. So that's how you can just kind of understand variation. So it's not so much difficult. It's something that is very simple and easy, ladies and gentlemen. Okay. So now finally, let us look at the graph of inverse and also direct variation. Okay. So now we look at the graphs of variation. So we'll look at two graphs. So the graph for direct and that one for inverse. Okay. So when you're looking at the graph of a direct variation, okay, it's just as simple as drawing this simple graph. Okay, so you can have numbers there like 1, 2, 3, 4, 5, and the 1, 2, 3, 4, 5, for example. So in direct variation, the graph is that you can have something like okay. So you can have a graph like that. Let's say this is a 1, 2, 3, 4, 5. So this is 2, 4, 6, 8, and 10, for example. So you can have something like that. Okay, so this is we know that this is x and that's y. Okay, so when you look at this graph, meaning as the value of x increases, so when you're 1, even y increases. So you're on 2, even that increases. So if you're on this part, increases. So if x increases, you'll have y increasing there. If this also increases, that increases. So that's about direct variation. So as this value increases, so this one also increases in that direction, this one increases in that direction. So that's all you need to understand about the direct variation graph. Okay. And now for the inverse is that as one variable. Okay. So for example, this is x and that is y. So you can have, let's say this is 1, this is 2, this is 3, this is 4. Okay. And you can have something in that direction. So you can have okay. So you can have a graph that moves in that direction. Let's say this is 2, and this is, let's say, 4, and this is, let's say, 6, for example. So now what happens is that as the values of x keeps on decreasing, okay, the other value keeps on increasing. Okay, so if you look at it in terms of x variable, so when x is 4, y is 0. When x is 3, y is 2. Okay, when x is 2, y is 4. when x is 1, then the y is 6 there. So that is basically the understanding of what is called graphs of variation. So you must be able to tell that this is a inverse graph. Inverse graph, and this is the direct graph. Okay, so this one is a direct graph. Okay, so guys, thank you so much for watching, and I really appreciate for your support that you're giving me. For those who have not yet subscribed to our channel, please make sure that you do so. You subscribe so that you don't miss any of these updates that we're giving you, that we are sharing with you. So share, like, and also subscribe for more information. Thank you so much, and I'll see you in the next video.